The midpoint theorem states that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. Now there's a converse to this theorem also, and the converse says that the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Now, if you're having a problem understanding this theorem or you don't know how to prove this theorem, then you have come to the right place, because this video talks about the converse of the midpoint theorem and we are going to prove it in two different ways. So come on, let's go. Hey guys, this is Vikas Sharma welcoming you on behalf of Exponent to Success to yet another of our videos. And if you haven't subscribed to the channel as yet, do subscribe to it right now and do not forget to click on the bell notification too. In the previous video, we learned about the midpoint theorem, which said that a line segment joining the midpoints of two sides of a triangle is going to be parallel to the third side and is going to be half of it. Now, we did prove that theorem in the last video, and if you happen to miss that video by any chance, then the link to that video is in the top right corner of your screen. Just click on the link and you'll be taken to the video straight away. Now, if that theorem was true, then the converse of that theorem is also true, and we are going to prove the converse of it in this video. So first of all, if you want to write the converse of that theorem, then the theorem is right here on the screen. You can pause the video and write it down. The theorem says that the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. So in mathematics, there are different ways of arriving at the same solution, and that is the same in case of proofs also. When we are talking about proofs, there are different ways of proving the same thing. And in this video, we are going to prove the converse of the midpoint theorem, but we are not going to prove it only one way. We are going to use it two different ways to prove the same thing. So do stick around to the end of the video to learn both proofs. So the first way I'm going to prove it is by deductive reasoning, and the second way is by contradiction. So let's start with the triangle first of all. Let me take any random triangle. Let me take a triangle like this. And let me name the triangle also. Let me call it triangle PQR. Now the theorem says that a line drawn from the midpoint of one side of a triangle. So let me take the midpoint of one side of a triangle. Let me take that side as QR. Let us take a midpoint on it. So let's say this is the midpoint. So if this point is the midpoint, then that means that this side is going to be equal to this side. Now it says that the line drawn from the midpoint of one side of a triangle parallel to another side. So let me take a line parallel to PQ. So let's say this is the line which is parallel to PQ starting from the midpoint of the side QR. Now what we have to prove is that this bisects the third side, which is the side PR, into two equal parts. So first of all, let's write down what is given to us. So given a triangle PQR, that is given. Number two, let me call these points also as point X and point Y. Given is that X is the midpoint of QR, which means that QX is equal to XR. Third thing that has been given to me is that the line segment XY is parallel to the side PQ. So let me mark that also, that this is parallel to PQ. And now let's write down what we need to prove. So to prove, we need to prove that this point Y divides the line segment PR or the side PR into two equal parts. So we got to prove that PY is equal to YR. Now you remember how we proved the midpoint theorem, that we drew a line which was parallel to one side of a triangle, and somehow we proved it that it was a parallelogram, and it turned out that there were two triangles. We proved them congruent, and thus we arrived at the solution. So we are going to try the same method right now. I'm going to construct a line through the point P, which is parallel to the side QR. Starting from P, I draw a line segment which is parallel to QR. Now we have got another point. Let me name that point also. So let me say that this is the point W. Okay, let's write this also, that there's a construction that we did. So construction PW is parallel to QR. And let me mark that also, that this is parallel to this. Now to prove this, what can we do? We are looking at a figure PWXQ, which is something looking like a parallelogram, but I don't know yet if it's a parallelogram or not. Even if it is, we'll have to prove that it is a parallelogram. So what are we given with? We are given that QR is parallel to PW and that PQ is parallel to XW. And one of the theorems about parallelogram states that if two pairs of opposite sides are parallel to each other, then that quadrilateral is a parallelogram. And if you happen to miss that video by any chance, then the link to that video is again in the top right corner of your screen. Just click on the video and you'll be taken to the video straight away. Now we can just write that according to theorem, PQXW is a parallelogram. And if it is a parallelogram, then we know that therefore this side QX is going to be equal to PW. Therefore QX is equal to PW. So we have this side is equal to this side. Now we are looking at two triangles now. So we are looking at triangles PYW and we are looking at triangles XYR. Now if you look at these two triangles, we are looking at this side PW is equal to XR. So let me keep writing it down also, that in triangles PWY and triangle XYR, PW is equal to XR. We know that these two angles here, this one here and this one, vertically opposite angles, so they have to be equal. So we write that angle PYW is equal to angle XYR being vertically opposite. And what else we have? We have that PW is parallel to QR. So if they are parallel and PR is a transversal between them, then that means that this angle here on top should be equal to this angle here. Now if because they happen to be alternate interior angles. So let me write that also down, that angle YPW is equal to angle XRY. And the reason I can write is that they are alternate interior angles. Now what do we have here? We've got a side, we have got two angles. Here also we have got two angles and one side. So this is not the included side, so it is not going to be ASA, but we can say by AAS congruence rule. Now we'll have to name the triangles, which triangles are congruent. So let me write triangle PYW. So imagine PYW. So we are coming from the angle with the double mark to the angle with the single mark. So that will be congruent to triangles angle with the double mark to the single mark. So RYX. Now once we prove that these two triangles are congruent to each other, we can say something about the congruence of parts also. And one of the congruence of parts that I can talk about is that now once if we rotate this triangle from the point Y, the triangle on top, if we start rotating, we will notice that W will go and sit right on top of X and P will come and sit right on top of R. So that means that PY would be equal to YR. And we can say that that is by CPCT, which means corresponding parts of congruent triangles. Now what did we have to prove? We had to prove that Py is equal to Yr, and we have done that. So that is the proof of the converse of the midpoint theorem, that a line drawn from the midpoint of one side of a triangle which is parallel to another side bisects the third side into two equal parts. Now in the beginning I said that I'm going to prove this theorem in two different ways. One of the ways was by deductive reasoning, which we did just now, that we did a construction and by deductive reasoning we proved that this was a parallelogram, and because this was a parallelogram then these two triangles are congruent to each other, and if they are congruent to each other then this side is equal to this side. So there's another way of proving it, and in case I do that I just prove it by contradiction. So let's go to the other figure straight away. Let's start with a triangle again. Now this is a triangle that I have. Let me name the triangle again PQR. And we have a midpoint of one of the sides. So let's take the midpoint of PQ this time. Let's say that this is the midpoint. And let me name that point as D. And the theorem says that a line drawn from the midpoint of one of the sides of a triangle parallel to another side. So we are going to draw a line which is parallel to another side. So if I've taken D, I'll take it parallel to the side QR. I can also take it parallel to PR, but let me take it as parallel to QR. So a line drawn from D parallel to QR will bisect the third side. So let me call this point as E. Now what we are given is that D is the midpoint of PQ. So that means that DP is equal to DQ. No doubts about that. We know that this line DE is parallel to QR because that is a line which is drawn parallel to the third side. And what we have to prove is, so let me write the given once again. So given PD is equal to DQ. Second thing that we are given is that DE is parallel to QR. And what do we need to prove? To prove that PE is equal to ER, that it bisects the third side. So PE is equal to ER. That is what we need to prove. Now this time I'm going to prove it by contradiction, not by deductive reasoning. Now let me start with the assumption that E is not the midpoint of PR. So I write that let us assume that E is not the midpoint of PR. Now if E is not the midpoint of PR, then of course there has to be another point somewhere on PR which will be the midpoint of PR. So let us say that it is this point over here. Let me call that point as F. Let us assume that F is the midpoint of PR. Now if F is the midpoint, let us draw a line connecting D to the point F also. So we can write construction join D and F. Now if D is the midpoint of one side and F is the midpoint of another side PR, because we are assuming that F is the midpoint of PR. So if D is one midpoint of the side PQ and F is another midpoint of the side PR, and if we draw a line segment DF joining the midpoints of two sides of a triangle, then according to the midpoint theorem, I can just write it as MPT for short. So according to the midpoint theorem, EF is parallel to QR. Now because according to the midpoint theorem, it says that a line joining the midpoints of two sides of a triangle, so D is one midpoint, F is the other midpoint, because we assumed that F is the midpoint of PR. So a line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. So therefore if DF is the line segment which is joining the midpoints of two sides of a triangle, it is going to be parallel to QR. So that is what, there's nothing wrong with our deduction. Now this is going by deduction. So we have taken an assumption in the beginning, and now we are deducing from each step that what should be correct. Now according to the theorem, we proved the theorem to correct, and if the theorem was correct, therefore this also has to be correct, that DF is going to be parallel to QR. Now that cannot be correct, can it be? Because what we can say is, but DE is parallel to QR. That has been given to us. Now if it has been given that DE is parallel to QR, then there cannot be another line passing through the same point D which are both parallel to QR. Imagine it this way, that if this is a line and this, I've got a point over here, then a line passing through this point is parallel to this line. That is true, that can be there. But passing through the same point, can I have another line which is again parallel to this? No, that cannot be true, because if it is passing through that point, it has to coincide on that line, right? Therefore, the only way this is possible, if this was given, this has to be true. The only way that is possible is that F should also coincide on E. So we can write, but this is a contradiction. A contradiction means that this cannot be true, which means that one of the things is false. Now this cannot be false because this is given to us. So this we have to take it as true. This cannot be false. So this has to be true. The only other things that we took into consideration were all by deductive reasoning, and hence they cannot be false. Then the only thing that we assumed, so only thing possible now left now is that our assumptions were wrong. Therefore, our assumption that f is the midpoint is false. Now if that is false, therefore we can say therefore E is the midpoint of PR, and hence or therefore PE is equal to ER. So if E is the midpoint, then PE is equal to ER, and this is what we had to prove here. So hence proved. Now see, we have proved the same theorem in two different ways. One was by deductive reasoning, the other was by contradiction. So like I said, mathematics, there are different ways of approaching the same problem. You can also try those different ways. There are in fact different ways available to most of the problems in mathematics. I can do it in a different way, you can do it in a different way, and it's all about logic. Mathematics is always about logic. Do not forget that logic ever. Now if you proceed with logic, I can assure you guys that you'll never have a problem with mathematics, because as long as you are going with logic, you are going to arrive at the right answer. So just tune your minds towards logical things, that if this is true, then what else can be true? If that is true, then what else can be true? And if you proceed logically, you will surely arrive at the correct answer. There is, in fact, no reason to get scared of mathematics. There's no reason to get scared of geometry, because everything is logic. And this channel, Exponential Success, is going to teach you logic only. It's there only to help you understand all these things. And if you haven't subscribed to the channels yet, just do so by clicking my photograph here right on the screen. And while you're doing so, do not forget to hit on the notification bell also, that because that will ensure that you do not miss out on any future content from us. And do watch these videos appearing on the screen right now, because I assure you these are going to change your life. So take care. God bless.